Okay, this is the inequalities question. First one, linear inequality. Most people are better at these. For this one, you just do ordinary rearrangement, and you're going to have some number of x's is greater than some number, so you just subtract and add things from both sides to get that. You divide. If you happen to be dividing by a negative, you have to flip the inequality sign, but that should be easy. Do simplify your answer, so if you've got even numbers on the top and bottom, it's best to simplify to a nice fraction. Okay. Part B is a quadratic inequality. It's got x squared in it, so the recipe for that is you rearrange again and you get less than or equal to naught. Okay, this will be a quadratic as long as you've got a plus number of x squared there, which you're very likely to. Remember, the method for a quadratic inequality is not just finding the critical values, but a graph. If you've got a plus number of x squared, the graph is going to look like this. Okay, but so the factorizing and the critical values, that's the bit that most people can do. So you solve the equation x squared minus 9x, and it's going to be minus 36, isn't it? Equals naught. Factorize that, find out what these two values are, but that's solving an equation. That's two values that x could equal. Okay, having got your two values that x could equal, you then think, okay, where do I want to be in this graph? Well, I want to be, when you've rearranged it, you're going to have, a less than or equal to sign. You're going to be less than or equal to naught. So remember, the x-axis is y equals naught. So less than naught is y less than naught down here. So you're going to want this bit, so you've got the case where there's just one solution. So the solution's all going to be on one line. Okay, so you're going to have this critical value, you're going to show x in between them, and you're going to put the correct inequality sign both ways round between those two limits. Okay, so you need to be able to use your sketch correctly. Okay, and then for the last bit, all right, well, from part one, you've got x is going to be greater than some value, so it can't be that value, empty circle, but it could be all the values greater. Okay, and in the second part, x is between two values. Okay, now I may be drawing this slightly wrong because I'm guessing that the two values, there may be one down here and there may be one up there. So the second x is these, and it can equal that endpoint and equal that endpoint. But then we need the section of the number line that's shaded in both diagrams. Okay, so that would be from the empty endpoint up to this solid endpoint here, those two values. So these two values become the limits, and it looks a little bit like your solution. It's in one piece like your solution to part B. Okay, but now you have two slightly different, they point the same way, but two slightly different types of inequality sign, because this one's not allowed to equal and this one is allowed to equal. Now you have examples of this kind of question in your notes, in your booklet. Get this nailed, because this part C is quite a popular follow-up when they've done a linear and a quadratic inequality in parts A and B.